So if we're charging with no contact, that would be induction charging. So if we're charging with contact, what does that leave us? Conduction charging. Okay. Good. So now we're gonna move on. Well, let's see. Okay. So polarization, and I referenced this the other day. This is not the creation of an actual charge. It's a surface charge. Remember I said it was a weenie charge? It's not a real charge. I know it's a terrible term, but I kind of enjoy it. So it's not a real charge. You can make fun of it all you want, but you can polarize the surface. And this generally, we see this more in insulators because insulators are loath to give up or gain electrons. They're not really well set up for electron flow, but the electrons within them will move. They just don't tend to leave the material. So what you end up with is all the electrons sort of aligning in a particular way that part of an object will have a positive surface charge, part will have a negative surface charge. We can do this with lots of things without loss. Now, what you were doing did involve loss. In some cases, you were probably actually just polarizing objects if they were not then grounded. And it is, admittedly, it's tough to distinguish, and it's tough to think about the flow, and it's tough to determine. Like I said, the groups that started to compare objects were probably coming the closest. So in the process of all your testing, nobody asked me to do any kind of setup like this. Now, with a lot of these things, some part of the object was generally in contact with something that would come back to Earth, like your hand. You can ground an object just by holding it. One way to get around that is to suspend an object. And this is actually pretty standard if you're really doing charge experimentation. I wanted to see if anybody would come up with it on their own, and they didn't, and that's okay too. But if we do suspension, and we have to make really sure that it's not touching the upright on the post, we can generally, and I did a little bit of this, people were looking at it yesterday, we can generally get better charge. Now that's not grounded. I am, therefore this is. If I touch them, should we have electron flow? We should. Because I was getting them to sort of attract earlier. Now let's see if it changes the behavior. Oh, look at that. It was attracted. Well, I just touched them again. Okay, here, I'm going to reground that. Try to get it to be still. Be still. Okay, this is all grounded. I'm all grounded. I always have to think all these through really carefully. I can hear snaps and crackles and pops and fizzes. So right now, this is attracting the acrylic rod. Now, what if I touch them? And recharge this. Do I get attraction or do I get repulsion? Ooh. Or do I get the string? Okay, wait, I'm still getting attraction. Okay, well, it's imperfect. This is a Triboelectric series, though, so let's actually look up a Triboelectric series. In the Triboelectric series here, and if you can't read it, I guess that is pretty small. Which of those things did you have? Human hands, asbestos, rabbit fur, acetate, glass, mica, human hair, nylon, wool, fur, lead, silk, aluminum, paper, cotton, steel, wood, amber, sealing wax, hard rubber, mylar. Ooh, I should get some mylar balloons. That'll be for next year. Nickel, copper, silver, UV resist. I don't even know what that is. I mean, I know it's a chemical that's used to protect substances against ultraviolet radiation, but I'm not sure what the chemical component is. Brass and stainless steel, gold or platinum, sulfur, acetate or rayon, polyester, celluloid, styrene, Orlon, acrylic, saran, and I should put some saran wrap in there, polyurethane, polyethylene, polypropylene. That would be an easy one. I've got that for backpacking gear. PVC, which we have, Cal-F, silicon, Teflon, and silicon rubber. Okay, so I can get a couple of those and add them to the box. So you guys obviously had human hands. Wasn't listed on your sheet, but you all have them, and you were all transferring electrons. We obviously are not playing with asbestos in here. We didn't have acetate, but we did have, so we had human hands, we had acetate, oh no, we didn't have acetate, we had glass, human hair, wool. I think the fake fur functions the same way the fur does. We had silk, we had aluminum, we had cotton, we had acrylic, we had the PVC pipe. That's it, right? So the Triboelectric series is arranged where these things tend to acquire a positive charge. Those are the things that tend to give up electrons. So the human hands tend to give up electrons. Glass tends to give up electrons. If we're charging the PVC, so let's do some comparisons here. If we take PVC, which I just did, and rub it with fur, what gains electrons, what loses them? The fur gives them up. The PVC should be gaining. Now, based on what you saw with the glass, and I'll remind you that glass is up here. If I charge the PVC rod with the fur, so we now assume the PVC rod is somewhat negatively charged. And, oh, it was grounded though. So it was, okay, so see, you have to think your way through every single one of these. So I'm holding the PVC rod, I'm rubbing it on the fur is going to give up electrons. We would assume then those electrons would flow through the rod to ground. Well, I'm not a great conductor. To do a better job establishing a triboelectric series, we have to be better with our grounds. And this was very informal kind of stuff, but it forces you to start to think about where the electrons are moving, and that was really the whole goal. So next year maybe I'll expand that and I'll make them actually make a triboelectric series. Wouldn't that be fun? That'd be lots of fun. They'd love it, I'm sure. They wouldn't whine or anything. And I can add some more stuff from the list. Okay. How many of you did think that the hair and the wool were gaining electrons, or were losing electrons? Did you assume that they were losing or gaining? I mean, you knew there was movement. You thought they were both based on circumstances. Okay. Well, and that's the other point we talked about, and that's a good point. Note that cotton doesn't really have a tendency to gain or lose electrons. Cotton's the least charged thing. And if you've ever worn something polyestery in the winter and had it stick to your body because it's clinging because of static electricity, cotton doesn't do that. It's one of the reasons I like cotton. Cotton doesn't crackle. Pure cotton sheets don't generate static. Who knows the blankets or sheets static trick? Have you not done this? Seriously? Oh, for goodness sake. Yes, I'm giving you all homework. Except for you, because you've done it. You're excused. Everybody else has homework. Go home. Find a blanket that's synthetic. Most comforters from Kmart or wherever are largely synthetic. Dry room. Turn off all the lights. You have to do this at night. You can't have any light. Put your little footsies under the blanket, sit in bed, and snap the blanket up and down until you see sparks. Can't believe none of you have done that. Yes! Yes! Yeah, especially like fuzzy. Oh my god, I hate polyester pajamas because of this, because I hate static. But yeah, it's great for seeing static sparks. So go home and do this. I can't believe that half of you have never done this. You are so deprived. Anyway, go home and make some sparks. But that's what's happening. Cotton sheets won't do that because cotton's fairly neutral. So for the materials that tend to gain electrons, there are some that are closer to neutral than others. We didn't have a big chunk of amber because that's outrageously expensive. I can't afford to put a big chunk of amber in the box. But Mylar balloons, that's cheap. I'll have that next year. Those are not too far off. If you took Mylar and something like wood fiber, they both have a tendency to gain electrons, but Mylar has a bigger tendency to gain. Take one of those and put it up against silicone rubber. That's easy. I can get oven mitts for that. The ones that are closer to that no gain, no loss may actually give some up. Not well. It's not like rubbing them against wool, but they may actually give some up. Does this help with the charge stuff? Okay. So that's about all we're going to say on that. I want to move on to force, and we're going to demonstrate it.